Next up in chapter 2 is going to be linear functions and models. So we're basically just combining stuff we did at the beginning of chapter 2 with all the function notation, how to interpret different f of x's, plugging in x's, y's, domains, ranges, combining that with linear model stuff we did last unit. So finding the equation between 2 points, etc., all that stuff. So let's go back to a problem we've done before. Okay, and that's the donut problem. So we've seen these numbers before. We've come up with an equation for it. But instead of asking you just to do something with the numbers, we're going to interpret it through function notation stuff. So if we say find the function d of x, representing the number of donuts remaining x minutes after the shop opens. So they're telling you your x variable is minutes, but if you think about it, time always has to be on the x-axis. Time looks really weird on the y-axis. So then up here is the donuts. Okay, so the first thing, let's just go ahead and find an equation. I mean, that's all a function really is. It's just an mx plus b. So I'm going to pause that and get you guys the equation because we've seen this before. Find the slope, slope-intercept, all that stuff. Okay, once we've got our equation, we've stopped before with just y equals, but it's asking for a function d of x. So the amount of donuts represents the d of x. X is the minutes. So all we're going to do is just replace the notation. Next question, evaluate d of 100. It gives you the x value is 100. So we're simply just going to plug that in. Okay, they gave us 100 minutes, so our answer here is going to be in terms of donuts. Next piece, find the number of minutes x such that d of x equals 200. So they're asking you to find this x in here. So this has to be the y value if you want to interpret it that way. So that's just getting plugged in right there. So simple enough. We know the y is 200. We just have to go ahead and solve this. Okay, basic two-step equation. Okay, we're solving for x, so we know that is minutes. So 75 minutes after they open, they got 200 donuts left. Last piece. When will the shop run out of donuts? When the shop runs out of donuts, that means the value of the function goes to 0. It's like the golf ball problem we've done before. So this is the same idea. We're just simply solving for 0 now. Right. Now, let's take a brief detour and just discuss how we graph these things again, in case it's been a while since you've seen them. So any y equals mx plus b. We know we're going to plot the y-intercept. So 0, 350, and then we're going to go down 2 over 1, put a point, down 2 over 1 with the slope, and this is going to come down this way like this. Now, if we have that picture, while we're here, let's just go do some domain and range for extra practice. Domain's the x values. So all this here. You can't have less than 0 minutes. When the shop opens, that's when it starts. That's minute 0. And it just looks like the shop runs out of donuts at 175 minutes. So this point right here is 175, 0. Range. All the y values. The minimum amount of donuts you can have is 0. The most you can have is 350. And just a little extra practice with that. Now, next one. Same idea, a little bit different scenario in as far as what they give you. So a road crew's got to clear a hill so that a new road can be built. On average, we've seen that before, they're able to clear 0.8 feet of the hill each day. After 10 days, the height of the hill is 80 feet. we think about x's and y's. If you have time, it always has to be your x. It just doesn't make any sense to put it on the y-axis. So we know we know xy is days comma height. So we just got the point 10 comma 80. On average, they're clearing 0.8 feet of that hill each day. When you see on average, that's your slope. That's your change. Okay, your rate of change is 0.8 feet. But I think everyone would agree the hill would start somewhere. If your slope's positive, it's going up. The hill's not getting bigger. The hill's getting smaller by 0.8. So given these two pieces of information, we should be able to find an equation. We'll come back and do the function stuff. So I'm going to pause that real quick. Okay, so negative 0.8x plus 88. So we'd come to the point 0, 88, and we'd go down 8 and over 10, down 8 and over 10, and we'd get a graph, and we can come back and do domain and range once we know what those actual values are. So first piece, find a function f of x that represents the amount of hill remaining after x days. So all we're doing is just replacing the y with an f of x. Negative 0.8x plus 88. Part B, evaluate f of 24. Okay, they're giving you an x is 24. So we're trying to figure out the height of the hill after 24 days. We would literally plug this in, go to your calculator, see what happens. Make sure we include some units with our answers, so it's another way to kind of check and make sure these things look right. Okay, next piece. Find the number of days when f of x equals 32. Okay, find the number of days. So we're looking for an x value, so that means this has to represent our y. So same thing as before. Throw a 32 in for your y value, and we're just going to solve. Okay, so we get 70 days for that. Last piece. When will f of x equal 0? Okay, f of x represents the height of the hill, so this question's asking, when will the height be 0? Height is your y value, so it's going to be an x comma 0. Do the same thing as before, just with a different number, and solve. Now that we have all that information, we get some points on our graph. So we know the height at day 110 is going to be 0. We know our y-intercept. We could do domain and range just for extra practice. So domain's all your x values. We can't have anything less than 0 days. It ends at 110 days. Range, starting at height 0, and it starts at height 88, and it can't get below a height of 0. So there's those two things there. Okay, next piece is this idea of scatter plots. And I just want to briefly run through a couple things with those, because I know you guys have seen them before. So let's take a look at something like this. So this is data we collected from another class, and it is your height in inches and the distance from your elbow to your fingertip. And there's all kinds of relationships and stuff with Da Vinci and golden ratio that goes with these. So basically, if you have a bunch of data, you should be able to put them on a graph. So by hand, it doesn't make much sense for us, but that's why we use computers and our calculators. Okay, so I kind of ask a bunch of different things here, but I want to briefly show you guys how you actually get these scatter plots. So first thing, okay, in your calculators, you are going to go to Stat and Edit, and you should have an L1, L2, and L3. And I know you guys have done these before, but it may have been a little while. If you don't have an L1, so let's say you go up to L1 and you actually delete it, okay? If it's in L2 and L3, you're gonna run into some problems. So let's say your L1 or whatever is gone. So I just deleted it. If you wanna insert one in there, second, insert, second, and then the 1 button, because you can see the L1 above it, and you can get it back. So once you have your L1, L2, L3, you're just gonna throw the numbers in there. And these correspond to the X's, these correspond to the Y's. So that's list 1, that's list 2. Okay, once you get the data all thrown in L1 and L2, if you want to see it again, go to your Y equals, clear out whatever stuff you have in there, go up to this plot thing, hit enter, make sure it's lit up, and then you can hit a zoom zoom 9, if this thing would ever stop. Okay, zoom 9 is zoom stat. So if you just literally hit zoom 9, it'll plot them for you. Okay, so you can kind of see the different relations between them. Okay, if you want an equation form on your calculator, remember we'll go stat, we can go calculate, we can do linear regressions, we can do quadratic regressions, we can do cubics, we can do quartics, whatever. Okay, so I did this in Excel just to get kind of a better picture, and you can kind of label them a little bit like that. But keep in mind, your data can be skewed. So what I mean with that is, like, yeah, this looks linear, and it looks like you could throw a really good line on there, and you could use it to predict different things. But our eyes are easily fooled by that stuff, and this gets into a lot of statistics things. So what if I grab this and drag this? You know, you can smush them together so it doesn't look so much. It looks a lot steeper now than it does like this. So that looks like there's a greater slope. Okay, that looks like there's not much change between them. You can really manipulate them kind of on how your eyes go with them. Okay, but once you get an equation, you can do the same things we've done before over here. So you can create functions, you can use it to predict different things. So we're going to do some stuff with scatter plots and whatnot. Here's just kind of some different pictures of what they look like. So I want to remind you guys, not everything we do is going to be linear, and you've seen that in Algebra 2, and not all scatter plots have a relationship that defines them. So here's just kind of 6 pictures of some different things. So this is a strong positive correlation. Yeah, it looks really linear. We could throw a line through it. It's going to be pretty strong there. Next one, moderate positive correlation. So not quite as strong as the first one, but it's still, you know, got in a positive direction. Just a bunch of dots, not much correlation to them. Okay, and then you can have a moderate negative, strong negative, and then this goes back to not all scatter plots are linear. Okay, this could be maybe a quadratic or a cubic or a quartic or maybe a log or something. But like I was saying, you can really change the relationships between them. So these look really, really strong and positive now, but if I do this and stretch it out, that slope changes. So it's not quite as steep anymore. Like this non-linear one, you can change it from being a steep curve like that to more mellow. The no correlation one, you can really stretch it out, so it's just kind of a bunch of random points. So our eyes are easily fooled, but that gets into a lot of statistics stuff. Okay, I'm going to throw a couple questions up on a link at the end of the blog. I'd like you guys to take a few minutes and throw those into Google Form, and we'll see you in class to practice these skills.